All right, so welcome back to the session for today. So today I want to have a revision session concerning our quantitative methods as a course that we discuss on this channel. So you want to make sure you stay tuned, make sure to like the video, share it as well, so that others always get the benefit to always join us that particular case. So let's begin right away without wasting my time and bring up my board so we get going with that case. So we are going to go through the following questions as you can capture it on your screen there. So these are the 3 questions that I've gathered to share with you on quantitative methods for business. So just want to go through some of them as a guide to know how far we are going through the course generally at the end of the day. So let's begin the journey smoothly. So question 1, we are asked you if y is equal to 7x to the power 2x, find dy over dx. So first differential, how do we go? Very simple, straightforward. What I want to do is that this is actually what? An exponential what? Differential. So what do? When I have applied what we call log on both sides of the equation. So when I have what? Log y to be equal to what? Log what? 7x to the power 2x. So once you have that, the next thing you want to do is to what? Apply the laws of logarithm. We can see this as an application of law of logarithm. This where we can capture in what? The third law or the power law generally there. So that's what we're going to do here. So we're going to say that here we'll write log 7x to the power 2x as what? 2x log 7x, and that should be equal to what? Log what? Y. So once you get it, the next thing you want to do is now to what? Differentiate the expression generally for the first differential. So it said that when it comes to differential of logarithm function, when I differentiate log function with respect to y and it's with respect to x, I'm supposed to get what? Dy over what? Sorry, let me check up my, okay. It's supposed to be what? Dy over what? The x, and then divided by what? Y. This is what you do. And that should be equal to, or better, so let me bring that up here so we can have a clear feel of what is happening generally here. So if I should differentiate log y, I'm going to get what? Dy over dx, and then divide by what? Y. Okay, and that should be equal to, now you can see that 2x and log 7x is actually what? Product of two functions generally there. So what do? You just have to what? Hold 2x and then differentiate what? Log 7x. After that, we say plus. Then we differentiate what? 2x and then hold what? Log 7 what? X. So what do we do here? We hold what? 2x here. And we differentiate what? Log 7. What you're going to get what? Differential of 7x. You're getting 7. So that we divide by the original function is what? 7x. That is the approach to differentiation of logarithm function. We are not done because this is a product of two functions. You introduce what? Addition. You introduce addition. And since at first we held that of 2x, the next thing we want to do is to hold what? The log 7x and we differentiate 2x. So we're going to have what? Log 7x. Oh, you can see. Okay, let me bring it. I thought I haven't checked this. Oh, sorry for that. It's supposed to be something like this. Yeah. Okay. So here we actually what? We hold what? Log 7x and we differentiate 2x. Supposed to get what? 2. So I can say to bracket 2 there. To bracket 2 there. Okay. All right. So once you are getting this, then we are good to go. So now we can say that dy over dx here is supposed to be what? Less flow. Quite I know that here the y can multiply with the whole of this expression, right? Can multiply the whole of this expression. So it becomes what? Y into bracket. Then remember, 7 can cancel 7 here. X can also cancel x here. So we are left with 2 in the bracket plus. Then we have what? We have log 7x we can say dot 2 or to bracket 2 the same, but because you are introducing a bracket here, we want to bring in what? Dot 2 here, bracket close. But you and I know that the value of y is equal to what? The value of y is equal to 7x to the power 2x. So we can introduce that in the equation here. So it becomes what? dy over dx to be equal to what? 7x to the power 2x. Okay. Into bracket 2 plus log 7x dot 2 bracket close dot 2 bracket close bracket close. Okay, so once we get that, then we can hopefully do some factorization in the bracket. We can say that we have what? dy over dx to be equal to, so I can bring in the 2 out. So that means I can have what? 2 dot 7x to the power 2 x into bracket I'll have what? 1 here plus log 7x bracket close. So therefore I can say that my dy over dx should be equal to, you realize that the 7x can be separated, right? So we can have 7 dot x to the power 2x. So I can then multiply 2 and 7, supposed to get what? 14x to the power 2x into bracket 1 plus log 7x, and you are done. This is how we go with the differential of what? Y is equal to 7x to the power 2x. Right, so let's take note of that. So that is the first step that you would have. If you have any question, you want to throw in a chat for us as you move along in our revision section on quantitative methods. Do also like the video as well and share it out with your friends generally. So we are asked to differentiate what? This function again. So this is also more of differential. So we have what? Y. So this is more like what? Higher, say higher power, what we call, is it chain rule approach, or power law kind of question in a more expression for algebraic form. So we have what? Y to be equal to what? 4x to the power 3 plus 13 all to the power 4. Here it's just a one-step approach you want to adopt. Very simple one-step approach you want to adopt. Okay, it is just a one-step approach you want to adopt generally here. So what do we do? Straight up, we can say that we have what? Here, all I want to do is first differentiate what? The power, which is what? The 4. Okay, differentiate the power, which is the 4. So you're going to have what? dy over dx to be equal to, so you bring the 4 in front of what? The expression 4x cubed plus 13. And after that, you differentiate what? The term in the bracket individual or independently. So differential of what? 4x cubed supposed to get what? 12x squared. Differential of 13 is a constant, so you get 0, so you don't bring that into the equation, or you don't bring that into the scene. And then after that, you repeat the whole of the expression given in the question, which is what? 4x cubed plus what? 13, and have your power as minus when you subtract 1 from what? The 4. Subtract 1 from what? The 4. So once you subtract 1 from the 4, then you can therefore say that your dy over dx then supposed to be, so here we can then deal with the 4 and the 12. So we'll have what? We will have 48 x squared, okay, into bracket 4x cubed plus what? 13 to the power 3, and then you are good to go. This is how you also go by the differential of what? A power kind of rule, or if you want to apply the chain rule too, you can use that. But here, very simple. First of all, bring the exponent to multiply the coefficient of the expression, then differentiate the expression individually in the bracket. That's individually, and then after that, you repeat the whole of the expression with the power and subtract 1 from the power. That is all. And you're done with the differential of such kind of function that you want to understand. So let's take note of that. So that is question number 2, and respectively, the answer is supposed to have at the end of the day. Now, question number 3. Question number 3, it goes like this, that a car dealer sells to Let me bring up this so that I can see what is happening here. A car dealer sells 2 brands of Ford car, that's Hyundai and Toyota, and 3 models for each of the brands. That is what we have for sedan, pickup, and then coupe. The inventory of the cars is shown below. The inventory of the cars is shown below. So we have what? The inventories of the cars. So we have the first one here. And going to tell us that if the dealer make the sale the following month. Let me read it again. If the dealer makes the sale the following month, if the dealer makes sale the following month as given by the table below, find the new inventory. So this is the inventory that we have in stock. Follow carefully. This is the inventory that we have in stock. Okay. This is the inventory we have in stock. All right. And then it tells us that if a dealer makes a sale for a particular month, right, as given in the table below here, as indicated with the red pen here, then what will be the new inventory after the sale of what? This. That's a Toyota and then Hyundai with their models of brand that they. So that means this is what we have in stock and this is what we have sold. So that means the question wants us to find what the remainder of the inventory in stock. So what do we do? It is an application of a matrix. So you just want to represent the matrix form and then subtract what we sold from what was in inventory, and then whatever we're going to left going to be what we call the closing inventory at the end of the day. That is for the Toyota and the Hyundai. So that is the idea behind what we're supposed to do. So what do? Just have to represent them in the form of a matrix, and then we flow in that particular guide. So let me say this is I can represent the whole of this as what? Can represent the whole of this as what? Inventory in stock. So I can say IX inventory in stock, or let's say inventory in stock. Yeah. And I can also represent this as what? As inventory sold. So to differentiate, let me bring in blue here for you. So inventory sold, the same thing. So that means if I subtract the inventory sold from inventory in stock, or let me do something like this. So let me bring in the red. You like say we have inventory and we have sold. The one that we have sold it out so that we can make a clear distinction. So inventory so that means at the end of the day, are looking out for how much of the inventory is what left at the end of the day. So what do we do? So we say that inventory left. So we say that inventory left supposed to be what? It's supposed to be what? Inventory that we're having in stock, which is the I minus the inventory that we have sold. So that is what? X. That will give us inventory what left. So let's represent this in a form of what? A matrix, so that we can have the feel of what we are trying to bring up body. So this actually can be an issue about it can be more like what? A 2 by what? 3 matrix having 2 columns and then 3 rows. So we have the first one up here. So I can have here as what? In my box, I'll have as what? 5, 5, 3, and then 2. I have here to be what? 8, 4, 1. Then minus. Then we also talk about the inventory that was sold here. It's the same order, which is what? Which is 1, 2, 0. Then we have 3, we have 0, we have 1. So that means we are subtracting to get what? Our inventory in stock. Inventory left, sorry, inventory left. So what do we do? So it's just what? Corresponding element subtraction so that we get the result. So we subtract 1 from what? 5. So we are subtracting what? 1. Next one from what? 5 here. Okay, so what do we get? When we do that, it's supposed to get what? 4 here. Then we do same with the 2 and then that of what? The 3 till we exhaust the legs generally here. So we subtract. Okay. So we are going to get what here? We are going to get 1. Then 0 from 2. Suddenly we are getting 2. Then we do same. 3 from 8. We are getting 5. Then 0 from 4. We are getting 4. Then 1 from 1. We are getting 0. So at the end of the day, inventory level is going to give us what? 412540. 412540. And this is how we find the inverse. So this is actually the application of what sums and difference of a matrix, but it was put in the form of what? A case or a story for you to decode it and then write in this form. So let's take note of that. Question number 4. We have been given this expression that if the determinant of a matrix 2x35 is equal to 13, find the value of x. So this is a 2 by 2 matrix in terms of finding determinant. And you haven't watched the video we just posted, I think that was last week or so. Yeah, we posted a video on matrices. I think so. Yeah, you have made a video on that. So make sure you want to go through because you have covered all this area. That will help you right after this presentation. You can go through and then get the dictates of what how it goes generally there. So here we are asked to what? We are asked to find the value of x. So, and you have also been given what? The determinant, which is what? 13 here. So therefore, to find determinant is going to be what? The product of what? The upward what? So this is what we are looking at. We are looking at what? This, right? Downward diagonals compared with the product of what? Upward diagonals. Compared with the product of the upward diagonal. So all that we can do or do here is that determinant is going to, determinant in value as 13. So we can say that 13, okay, should be equal to the product of the downward, which is what? 2 multiplying 5 compared with the product of the upward, which is what? 3 multiplying x. So now we can then solve for what? X generally here. So all I want to do here is to say that we have here to be what? 13 to be equal to what? 10 minus what? 3x. Okay. So what do we do? I can then say that here, let me bring that up here. So I'll have here as what? 13 minus 10 to be equal to negative what? 3x. Okay, so what do? We have here to be 3 to be equal to what? Negative 3. So therefore we have negative 1 to be equal to what? X. So therefore the value of x in this matrix is supposed to be what? Negative 1. So let's take note of that. This is how you find determinant of a 2 by 2 matrix. You find the product of what? The downward arrows compared to the product of the upward arrows. I've indicated here as what? Yellow and then the red pen that you can clearly see here, or the highlighter that you can see there. So that is how we go by that. So let's take note of that. Then certainly we have question 5. It's going to tell us that we are to, this actually what? This is actually an indefinite integral. We are asked to evaluate whether elongated s attached to s cubed minus 3x plus 1 over 2s cubed dx. Very simple. Once you see the question, just relax and then see how it goes. So I can, before I even start to integrate, okay, I need to rewrite something down before. So I can have here as what? S cubed minus 3x squared. So I need to rewrite what? 1 over 2s cubed in a more line form. By line form, I want to rewrite in the horizontal form to get rid of what? The fraction. So that means I can write as what? Plus 2x to the power negative 2. So we're going to have 1 over 2x. Oh, sorry about that. Not necessarily that. You're going to have something like this. 1 over 2 is only the x that will take the effect. So you have 1 over 2 x to the power negative 2. So if I have 1 over x is the same thing as what? X to the power negative 1. If I have 1 over x squared is the same thing as what? X to the power negative 2, in that order. Okay, so that's what we are doing generally here. So that will mean that once I'm done with the rewriting, then can close my bracket and bring the x. So now once we are done, we can then integrate this function generally in that particular case. So how do we integrate the function then? Pretty simple. We can integrate this. Pretty simple. So all I want to do here is that here, this is what we are having generally here. So we want to integrate. So by integration means that we are going to add 1 to the power of the variable, that is the independent variable, in this case x, and then whatever we get as a result of the 1 being added to the power, we then divide by the term in that particular expression or function. So when we go by that approach, that means that here we are going to add 1 to the 3. So we get what? X to the power 3 plus 1. So 3 plus 1, we are getting 4. So we divide by what? 4. Very simple. Minus. Then we do same with the 3x2. We will have what? 3x to the power 1 plus 1. Okay. And then divide by what? And then divide by 2. Then we do same here too. So we have what? 1 over 2 x to the power negative 2 plus 1. So x, that is minus 2 plus 1, is going to give me what? Negative what? 1. So I will divide all by what? Negative what? 1. So what will you get at the end of the day? You're supposed to have something like this. So let me bring in, have something like this. We can have what? Here as what? X. So we can write this as what? 1 over 4 x to the power 4, okay, minus 3 over 2 x to the power 2. But note, because it's an indefinite integral, because you are not seeing any limits on top and down of what? The elongated x. So you are going to introduce a constant, say k or c, whatever you want to introduce is there. So you make sure you introduce that plus. So here too, we have negative being divided by the whole of this expression, 1 over 2 x to the power negative 1. So that means the negative will take precedence of the positive. So we are going to have here, so negative what? Negative 1 over 2 x to the power negative 1 plus what? K. So therefore, when we're writing this, I think you can see, let me zoom it down a bit for you. I zoom it down to you. Okay, I think this is manageable. I'm trying to bring this up a bit. Okay. All right. So that will mean that then we can write everything as what? 1 over 4 x to the power 4 minus 3 over 2 x to the power 2, okay, minus 1 over 2x. Because we said that if I have 1 over x is the same thing as what? X to the power negative 1. So that's what we are actually, so we are just reversing it back. So now it's in the form of x to the power negative 1. So to reverse it means you're going to have 1 over x. So that means the x will come and multiply the 2. So we have 1 over 2x, then plus what? K. Certainly plus k or c or any constant you want to choose, and you are good to go. So this is how we also integrate this kind of function. So you just want to make sure you understand it. If you have any question, you can throw in a chat. Do want to share the video, like it as well, so that others can as always benefit from this lecture in that particular case. So let's go for question number 6. Question number 6. Trying to zoom it better. I think you can see. Let me pull that like this. I'll read the other part for you to see, but for now, let's go. It goes like the total cost per day, that's the cost function in hundreds of cities for manufacturing a ton of steel. That is what is the a ton of steel. The part that you can see. Manufacturing a ton of steel is given by, so we have the cost function dancing here. So this is the cost function. We have what? 3 plus 10x minus x squared. Then in the form of this inequality, 0 less or equal to x less or equal to 5. We are asked to find the marginal cost if x is equal to 3.5 units levels of production. So we have been given the cost, and you are hearing what? Marginal what? marginal cost. You're now seeing marginal what? Cost. So if you are seeing marginal cost, then this should be a guide for you to know that we need to what? Find a change in cost. Find a change in cost. And the unit is what? 3.5 units generally there. Okay, 3.5. So of the production level. So straight up, we can say that to find the marginal cost, we need to differentiate the cost function. So that means we're gonna have what? Our I think this wouldn't help you. So we have what? Our marginal cost to be equal to what? The cost prime of x. And what will be for that? So the cost prime of s here. So we just want to differentiate the cost function. So we have here as what? 0. Differential of 3 is 0. Differential of 10, we are getting what? 10. Your differential of 10s rather, we are getting what? 10. Okay. And differential of s squared, we are getting what? Negative 2x. All right. We are getting negative 2x. So once we get that, therefore, we can say that our marginal cost of what? 3.5 should be equal, just have to substitute straight up. We have what? 10 minus 2 into bracket 3.5. So what do we get? We have here to be 10. So let me bring that up here. 10 minus what? Here I think it's supposed to get 7. Got 3.5 multiplying supposed to get 7. So at the end of the day, it's supposed to get 3. But we're told that we are working in hundreds of what? Cities. So that means that you multiply by what? 100 cities, kind of. So you're supposed to get what? 300 cities. 300 cities at the end of the day. So let's take note of it. So this is how actually it goes. You just have to multiply by that and you are good to go. Any question? We just want to throw in a chart for me in that particular case. All right, so that is the issue in relation to that. Okay, so that is that of what? Question number 6. So let's move on to question number 7 there. So we are asked to find the derivative of the function. Something that's funny me, so I just want to laugh more. Question 7. We are asked to find the derivative of the function f of x is equal to what? Negative s squared minus 4x. So we have to find the derivative of the function here. So how do we go? It's very simple to go. So first, you just want to differentiate each function term by term generally in that particular case. So how do we go? So we just have to bring in the function here. So we have what? Our f of x. F of x to be equal to what? Negative 8x squared. Okay, negative 8x squared minus 4 cos x minus 4 cos what? X. All right, so what do we do? So here, normal rule, don't mind me. I'm just saying so that's why I'm laughing. I'm smiling rather, not necessarily laughing. So what do we do here? Differential of what? Negative 8x squared is supposed to get what? Supposed to get what? Negative what? 16x. Negative 16x. But you can clearly see that negative 4 cos x is a product of two functions. So we have what? 4 and then cos x. So we just want to apply the product rule. So I'll first hold what? Negative 4 and I will differentiate what? Cos x. So when I differentiate cos x, differential of cos x is supposed to give us what? Negative sine x. So you have here as what? Negative sine x. But because this is a product function, at the end of the day, you're supposed to what? Bring in addition, because this is actually the product of two functions. So once we first held the 4 and differentiate the cos where we're getting negative sine x, the next thing you want to do is to then get back to the 4. We will actually what? Also hold the 4 and then we differentiate. Sorry, I think we will hold actually the cos x rather, and we differentiate the 4, and we know that differential of 4 is a constant that's going to result to 0, so you just have 0 there. So suddenly cos x multiplying 0 is 0, so therefore we can straight up say that our f prime, that's first differential f prime of x, is supposed to give us what? 16x. So negative, negative, meeting the negative sign is supposed to get at positive. So plus what? Plus 4 sine x, and the whole of here is 0, so we don't bring that into the scene. So that's how the differential also go for question 7, where we have what? F of x is equal to what? Negative 8x squared minus 4 cos x. All right, so let's take note of that. Let's take note of that. So that is what we need to understand generally when it comes to these kind of questions that we need to understand. If you have any question for me, just want to throw in a chat as we moved along in that particular case. Okay, so let's continue. All right. Then question number 8, suddenly you have been given a matrix question. We are asked to find what? Find the values of P and Q. Said that AB is equal to matrix AP is equal to what? P1, negative 3, 4, plus other matrix given here. So what do we do? So that means we must first find what? The product of what? Matrix what? A, and then that of what? P. So that once we get that, we can then equate that to P1, negative 3, 4, plus 3 multiplying, that's the scalar multiplication of negative 1, negative 3, 7, and then Q in that particular case. So let's see how we go with the multiplication of what? A 2 by 2 matrix. Here, calculator can work it out for you, but if you want to throw how we also deal with manually, just have to follow carefully and then get it right. Okay, so let's see how we go with the multiplication of AB. So you just want to create the section for this. So we have what? A multiplying B to be equal to. So let's see what we have for A. So A is what? Negative 2, negative 2, 4. Then we have here to be 5, 3. Okay. And we have B to be equal to, so we have B to be also equal to, so we are multiplying, right? So we have here to be 3, negative 2, then 1, then we have negative 3, generally here. Okay, so what do we do? Just follow the rules of multiplication when it comes to matrix. So what do we do? So here, what I want to do here is to bring in what? The rule. So we said that to multiply, first the first row of the first matrix, okay, we'll have to multiply it. We'll have to multiply it what? The first what? Column of the second matrix. At the same time, multiplied the second column of the second matrix. Okay, so the first row of the first matrix will multiply the first column of the second matrix, and at the same time multiply the second column of the second matrix. So that will give us what? The result row. That will give us the first row of the result. That will give us the first row of the result. So how do we go about that? Very simple. So you multiply 2, negative 2 by 3, supposed to get what? So you're supposed to get that as what? Negative 2 by 3, are getting what? Negative what? 6. Then you bring in plus. You are not done. Then you come back to what? The 4. Also multiplying 1, you are getting what? 4. So that will give us the first what? Entry of the row. All right, so let's go. Just want to clear something up. All right. So as we were engaging in, so -2 multiply 3, we are getting -6. Then 4 or multiply 1, we are getting 4. So that will give us the first element of the result row, of the first result word row. Okay, so once we get that, that is fine. Then the second word element on the same row, that's the first row of the result, it's also going to follow the same thing. So -2 multiply what? -2, supposed to get what? Negative what? -2 multiply -2, you're getting positive what? 4. Then half plus. Then positive 4 multiplying -3, you're supposed to get negative what? 12. So you just add up to what? And then we are done for the first row of the first matrix, multiplying the first column of the second matrix at the same time, second column of the second matrix. And then you come back to that of what? That of the second row of the first matrix to also does the same activity as engage with the first one. So what do we do? Straight up, we just have to what? Multiply 5 by 3. We are getting what? And that's going to give us what? The second word row of the result matrix in that particular case. So we have what? 5, okay, multiplying what? 3. We are getting 15. Now let me throw in this. So we have 15 here. Then we have in plus. Then we have 3 multiplying 1. We are getting what? 3. And then follow the same thing. 5 multiplying what? -2, supposed to get -10. Then you bring in your plus. Then 3 multiplying -3, you are supposed to get what? -9 there. So once we are done, we just want to deal with arithmetics generally here. So what do we have here? So I can therefore say that in writing a simple short, we will have here as what? Negative what? -2. Then here we'll have -8. Here we'll have 18. Here we'll have what? -19 there. -19 that you want to have. So that means that now we have AB to be what? Negative what? 2, -8. We have 18, -19. Okay, these are what we are having as the values of AB. All right, so once we have that, we just want to equate that to this. That is, we have what? We have P. Okay, we have P1, -3, -4, plus 3. Then we have what? -1, -3, 7, and then Q. So once we have this down, we can then do what we call our comparison, all right, in terms of what? To find the value of P and Q. So you realize that here, you see the position of what? The P. The position of P is on the first entry of the second matrix, that is after the equal to sign, the first entry there. So that means that we are going to take on the value of P in this form. Going to use the values up here, but generally we are going to focus on what? These values here. We are going to use what? 2. Okay, we are going to use the P itself and then that of what? -1 here to form the equation to find the value of P. Okay, so what do we do? So straight up, we realize that when it comes to the third matrix, it has a scalar of 3. So that means you're going to multiply what? The -1 by 3 so that we fit the equation generally there. So what do we do? Straight up, we can say that we have what? -2, right, to be equal to P plus 3 multiplying -1. That's how it goes generally. So we have what? -2 to be equal to P minus 3. And therefore, we say that we have what? So that -3 will join the -2, making it positive. So you're going to have here as what? 1 to be equal to what? P. And you are done with that. And then follow the same rule to do with that of the Q too. So the Q will have what? The same issue coming up. So we'll have what? Where the Q is positioned. You can clearly see that we have here the Q. So that will take into account -4 as well. And also that of what? 19 generally here. So in effect, we're going to say that we have here as what? Negative what? 19 to be equal to negative 4 plus 3 multiplying q, right? 3 multiplying q there. So that means that we will have what? Negative 19 to be equal to negative 4 plus what? 3q. Okay, 3q. So now you want to group like terms. So the negative 4 will join negative 19, and you're supposed to get what? Negative. Because when they join, become positive. So negative 19 plus 4 will give me negative 15. So I'll have here to be negative 15 to be equal to what? 3q. And then dividing both sides by 3, you're supposed to get here as what? Negative 5 to give me what? Q. So therefore, we conclude that therefore P, comma Q is equal to 1, comma what? 5. Negative what? 5. So that will be settling the values for what? P and Q. So let's take note of that. Let's take note of that. Let's take note of that. Okay, so that is the issue with respect to the matrix in question 8. Okay, now question number 9, we are asked to find what? The determinant of the matrix. So before we get to question number, I think I see some chat on Facebook. Let's see what they have for us on Facebook. So if you have any question, just want to throw in the chat for me. Those on YouTube, just want to throw in the chat for me. So we get going. So on Facebook, we have who? Let's see. Oh, I'm coming. We have Evangelist Parkwasi watching you live from Accra, Ghana. Okay, so thanks for joining us today on this section. And then he's saying that, can you, I think, go back to, is it question 6? You seem you don't understand that. I'll go back to question 6 and we'll see how it goes generally there. All right, so that is on Facebook. All right, so let's continue with the discussion. So I think question 6, I think I was looking at, we were looking at what the cos function there, and we're looking at the marginal cost. So to find the marginal cost, you must differentiate the cost function. So once you differentiate that, once the value of the output is given, once you differentiate the cost function, you just substitute the value of that into that marginal cost so that you get the marginal cost for that output that was given generally in that particular case. So let's take note of that. So this is certainly what I was trying to explain here. So you just have to find what the marginal cost of that, and then you substitute the output that was given in the question, and then you are good to go. So let's take note of that. Let's take note of that. So now that is question 8 that we just solved. Now question number 9. Remember, these are revision tips and questions to guide you towards our final exams on quantitative, but depend on the institution that you are attending to. I mean, it is a question that we have received from various sources, and we have gathered them together to assist students to actually excel in the exam. So you want to make sure you share and like it as well in that particular case. So you're asked to find what the determinant of a matrix. A is equal to what? 3, 4, negative 1, 2, 0, 7, 1, negative 3. Negative. So it is actually a 3 by 3 matrix. So here, most of the times, I always want to advise my student to adopt the alternative approach. I mean, that is the easiest way to naturally go. And what is that alternative approach? The alternative approach is saying that, hey, to find a determinant of a matrix, all that you really want to do is to what? First, write the original matrix given, and the next thing you want to do is to repeat the first 2 columns as an addition to the original matrix. So enough of the English, let's bring in action. So we have here as what? So I'll repeat this: 3, 2, 1. Okay, then I have 4, 0, negative 3. Then I have negative 1, 7, negative 2. Once I'm done with the repetition of the original question, I'll then have to repeat what? The first 2 column of the original question. So suddenly this one, right? 3, 4, 2, 0, 1, negative 2. I'm going to repeat it as an addition to the original matrix here. Okay, so we'll have what? We will have 3, 2, 1. Okay, 3, 2, 1. Then we have what? 4, 0, 4, 0, what? Negative 3. 4, 0, negative 3. So once you have this down, the next thing you want to do is you are going to find, or using the approach that we use in find determinant of a 2 by 2 matrix, the same you're going to use to also to find determinant from this question. So what do? We find the product of what? The downward arrows compared with the product of the upward arrows, and hey, you are good to go. Very simple. So we flow in that manner. So let's see. So here we are going to look out for diagonals. So we start with what? The downward diagonal. So we will have what? The first one certainly from 3 to what? 0, negative 2. Then second one certainly from the 4, 7, and then 1. Then the third one also certainly will come from negative 1, 2, and then negative 3. So that's going to be our downward arrows, and then we compare that to the product of what? The upward arrows. Very simple, right? So here too, you want to look out for diagonals. All right, so we can start from positive 1, 0, and then negative 1, right? And also look at negative 3, 7, and then 3. And then finally, you can also take into account negative 2, positive 2, and then positive 4. Okay, so that is what we need to certainly do here. All right, so let's take note of that. So once we have gotten the arrows, then we can find the product of these arrows. Okay, so let's find the product of these arrows. So we flow 3 multiplying 0 multiplying negative 2, it's supposed to get 0 here, so 0. Then 4 multiplying 7 multiplying 1, so 4, 7 is 28. 28 multiplying 1 is the same as 20, so we have 28 here. Then negative 1 multiplying 2 multiplying negative 3. So here suddenly we are getting what? Positive 6. Or negative, you're going to get positive multiplying 2, so supposed to get 6. Then once you are done with the downward product arrows, then we move on to the upward one. Here in this case, we are using the red highlighter here. So we have 1, 0, negative 1. So certainly 0 there that I just want to have. So 0 here. Then negative 7, negative 3 multiplying what? So let's go by this. Negative 3 multiplying 3 are going to get negative 6. Negative 6 multiplying 7 is supposed to get, I think 7, 6 is 42. So you're supposed to get what? Negative 42 there here. And then here too, negative 2 by positive 2, you're getting negative 4 multiplying 4, you're supposed to get negative 16. So once you are done with this, therefore our determinant A is supposed to be what? The summation of what? The result of the product of the downward, so which is what? 0 plus 28 plus what? 6. Okay, so we have what? 0 plus 28 plus 6. Then compare that to the upward, which is what? Which is 0 plus negative what? So let me bring that up here for you. Pull this here. So plus negative 42. Okay, then we have what? Plus negative 16 there. So let me bring that up here. Negative 16. So at the end of the day, we have here 28 plus 6 supposed to get what? 34. Then you have minus here to bracket negative 42 plus 16 negative. So you're going to get here to be 8. Here you're going to get 58. So you have what? Negative 58. Negative 58. Okay, negative 58. So what is happening here? Negative, you're going to get what? Positive. So we have 58. Okay, plus 34. You can check the arithmetic for me to see if I'm correct. But certainly I will just want to show you the principle, but you can get arithmetically wrong, I mean, in terms of addition and subtraction. So we just want to check to see if they are right. So here we're going to get 12, here 1. So we're going to get here to be 8. So 92, something like that. So you can check for me to see if the arithmetics are correct, right? In terms of even multiplication and this. So that means you're going to get here to be 92 as your determinant. If the arithmetic is right, then it's supposed to be right here. So this is how we find the alternative method in finding what the determinant. Very simple, straightforward to go. So let's take note of that.